Up Algebra 2 boys and girls, let's get this party started. So if you take a look at your class now, you're going to see that there's a lot of assignments, and yeah, that's kind of the way things are going to go now. Bradley's like, yay, back at school with Mr. Dolday, but guess what, Bradley? No more chemistry. I'm sure Bradley's like, sweet. Can't make the camera bigger so I can see the whiteboard. How's that? Did that work better for you? All right, cool. So we're going to be covering rational functions. We're going to be hitting a little bit of, here's our schedule for this semester. I think we're going to hit rational functions. We're going to hit a little bit of, or not a little bit, but then the next topic we're going to go into is basically we're going to be covering standardized test and how to take tests and that kind of stuff. And I'm going to basically do a whole topic on pitfalls of standardized tests and do as much as I can of that because I want to hit that before you guys take the ACT coming up. Then after that, we're going to hit exponentials, and even though exponentials will be on standardized tests, I figured that it covering that after rational functions but before exponentials won't hurt you too much. And then after that, we're going to cover statistics, and that pretty much brings us to the end of the year. I am a lot better set up this semester than I am from last semester. I have all the assignments already built and made for you folks. So hopefully everything will work out perfectly. I'll probably spend some time correcting any mistakes that I have, but I don't necessarily need to build everything from scratch. So we'll be sitting pretty good. Where's those pens I just got? All right. Let's get back into it. Let's get into talking about what we need to talk about today. Sounds good? All right. Rational functions. Any questions about anything before I get started? All right. And then this class structure is pretty much the same exact as last semester. There's nothing that's really going to change. The 8.1 recap, actually, I think that's a mistake that I might have put up there but not required that of you. Let me double check that real quick. Where did you find that? What section? The upcoming assignments part. Oh, let me see. I thought I might have deleted it, but my answer is I don't think so. Oh, I see, honey. Okay. I don't think so. In fact, what I'll probably end up doing, see, this was due on December 9th, and that's not fair. I think that was accidentally put in there still. What I'll do is I will go and give you guys the full credit for that thing already. Sound good? So don't need to do it. I'll just I'll give you the credit for it. All right, let's get this party started. How's the audio? How's the video? Can you guys see? I try to just get everything I can. Here we go. Before we get... All right. There we go. Okay. This is the problem with people touching my stuff. They leave all the markings here. Okay. Well, so let's say yeah, we're covering rational functions. I abbreviate it as RAT, as in rational. Hopefully these pens work. Junk. Junk pen. All right, what about this one? Can you see that? Barely? All right, let me try red. I don't like using red because it doesn't erase very nicely. How's that? Better? All right. So check this out. This topic is actually going to be, I feel like it's really easy topic, but it's a lot of fun. It's really easy for me to introduce, but it's going to be, to me, it's going to be a lot of fun to do, okay? So we're talking about rational functions. What you need to know for rational functions is you need to remember back when we were factoring things. You remember when we were pulling things out, like the distributive property, or actually instead of distributive, we were pulling things out. You also need to know how to factor things down, like for example, x squared plus 3x plus, I don't know, let's see, say, or x squared plus 3x plus, or plus 5x plus 6. Do you remember when we were doing something like that? Where we kind of went like this and this and this, and we have an x and an x, and then we let's see, we said, okay, well, what can make 6? Actually, this is impossible. I should make it a -5, and then you can go, okay, well, then you'll have negative there. Then you have -6 and a +1, or something like that. Oh yeah, I'm sorry. When it was plus and plus, for some reason I wasn't thinking about that. You're absolutely right. Plus and plus, and you can go 2 and 3. Yeah, 2 and 3, correct. All right, cool. But you remember this? This is old school. I don't need to reteach this to you, right? Now, there was something else that we did, and let me remind you of that as well. What if we had something like this, like x cubed plus 5x squared plus 6x. All right? The step we would take before we did this is we would actually do factoring on this thing. But the step we would take before we did this is we would say, there's at least one x in every single one of these terms, right? So I'm going to pull that x out. So if I pull an x out of here, it becomes x squared plus 5x plus 6. If I were to distribute this x back in here, it would give me exactly the same thing as I had above, right? So I can factor an x out. That is technically factoring. It's not as cool as the factoring that we just did before with the, breaking this thing down even further. But yeah, that's factoring, sure. Are we cool? All right. There's one baby step I need to remind you about before we cover this. Now, do you remember when we did polynomial long division? I made sure that you guys knew how to do long division. All right. Let me give you the recap, or let me give you the, hey, just remember that how to do this part of the of this lesson, and then we're going to apply it, okay? And this is adding and subtracting fractions. Now, if I have 5/4 plus 3/4, what's that equal to? 8/4. Yeah, exactly. 8/4, which is also known as 2/1, which is also known as 2. We cool? All right. Now, what is the, okay. What about like -4/5 plus 7/8? All right. What's the answer? This was easy to do, the 8/4 one, but this one, not so much. And why? Why is this one a little bit harder to do? Right. So it's that whole game of the denominators aren't the same. So we're going to have to play this game of trying to make a least common denominator. That's exactly it.
a least common denominator, and then we'll find the least common denominator that's between these two, and then combine them or make them the same denominator, and then we can add them. So how do you find the least common denominator? In this case, it would be 40. Because I kind of go through 8, and I go 8, 16, what's up, this is 24, 32, right? 40. And I say, oh, 40 is the first number that I can divide by 5. So yeah, I agree, 40. In fact, why don't I do it this way? I'm just going to say this is equal to negative 4 over 5, or sorry, 4 over 5 times 8 over 8 plus 7 over 8 times 5 over 5. Do you guys remember this game? And this was probably from 6th grade, I think, right? So then you go, okay, well, this is negative 4, so that would be what? Negative 32 over 40 plus 35 over 40. Yeah? And then, what is that, negative 3 over 40? Yeah. Oh, no, positive 3 over 40, because 35 is bigger than 32. Sorry. Absolutely. All right. Anything freaky here? Anything that you don't remember? Nope. Pretty good? Okay. Let's try another one of these just to make sure that we're good on this stuff. I'll try a couple of more of these. How's about 2 plus 13 over 4? All right. I'm adding a number to a fraction. It's really a fraction to a fraction. You can think of this 2 as 2 over 1. I can make that 2 over 1 as 8 over 4 plus 3 over 4, which is 12 over 4. Wait, no. 11 over 4. Right? No, you're right, 13 over 4. Wait. Oh, you're right. I'm sorry. That does say 13 over 4. I'm learning, like, what is going on here? No, you're right. You're right. You're absolutely right. I was wrong. All right, 8 plus 13, that's 21. Sorry, I screwed it up, but yeah. But you guys get this, right? This isn't new stuff, not any crazy stuff for you. Okay. I'm going to do one more idea before I get into like how to actually do this stuff. And it's this. Let's go with 1 over 9 divided by negative 4 over 3. Okay. Now here's another topic of like, hey, do you remember this? This division symbol right here, I don't like dividing fractions. It really bugs me. So what I'm going to do is I'm going to multiply the reciprocal of this. And to reciprocate this, you just take this thing and flip them upside down. So this is 1 over 9 times 3 over negative 4. Are we cool with that? Now, I can think of this 9 as 3 times 3. Are we cool with that? And then I can say, oh, I can cancel out the 3's because there's one on top and one on the bottom. So then what I'll do is I'll just say, okay, well, that's 1 over negative 12 because 3 times negative 4 is negative 12. We cool? And technically that's the same as negative 1 over 12 or just negative 1/12. Those are all the same thing. Are we cool with that? This isn't anything new. I don't feel like any of this stuff is new or confusing. This is just a, hey, remember this from 5th grade. All right, let's get into the topic because I'll be honest with you, we're pretty much done with all of the math for this section. It's actually a really, I would say, easy section. A nice one to kind of dip your feet into. All right? Let's try this one. 16x squared over 28x. Okay. First of all, this x squared can be thought of as x times x. You agree? So you can cancel out an x. Absolutely. All right. And then the 16 over 28, you can reduce that. Now, if I were to do it slowly, I would probably say something like, hey, that 16 is really 4 times 4. You still have the x up there. And then the 28 is 4 times, sorry, I'm not very good at math in my head. Isn't that 7? Yeah. So you can cancel out one of those. And so what is this equal to? 4/7 x, or 4x over 7. Cool. So what we're doing is we're taking polynomials and we're applying all of that easy math stuff that you learned from way back when, but we're kind of doing it in a tougher way. Here, let me do another one. 2x minus 6 over x minus 3. Okay? Now, can I factor out the top? Can I factor the top? Is there something that is in both parts of the top? There's a 2, exactly. Would you guys agree that that's the same top? I could pull a 2 out of there. Because if I put the 2 back, it would be exactly that, right? Now, is there something on top that I can cancel out with the something on bottom? Exactly, the x minus 3. So really, this thing right here is a secret code for the number 2. Not hard, really. Yeah, you just cancel them out. All right, let's try something even harder. How's about this? 4x minus 12, and on the bottom, there's a 2x squared minus 2x minus 12. All right, let me show you what I would do. Can I divide something out here? I can take a 4 out. Exactly, there we go. So I have a 4 times x minus, well, 12 divided by 4 is actually 3. Right? Done. I'm done with the top. We cool? I can take a 2 out of the bottom. Good, let's do that. 2 times x squared minus x minus 6. All right. Are we cool with that? Now, I can still factor the bottom. I'm not done factoring the bottom. I'm probably going to break this thing down by factoring it into 2 pieces, because this is a quadratic, so it can be in factored form, which basically gives you 2 parentheses. Here's my numerator. My denominator has this, and then I'm thinking that it's going to have something like that, the double parentheses. We cool? In fact, here's what I'm going to do. I'm going to use the numerator over here to give me a hint as to what I think one of these parentheses are going to be. See, we manufactured these problems so that they cancel everything out nicely. So I'm thinking, in my head, here's what I'm thinking. I'm thinking one of these is going to be an x minus 3. Yeah, and then Bradley figured out the other one's going to be an x plus 2. Good, yeah, and if I FOIL this out, that makes it perfect. We're good. We cool? So, what's on top and what's on bottom? I'll be able to cancel things out. I can cancel out the x minus 3. Yes, absolutely. But I can also deal with the numbers. 4 over 2, this 4 gets canceled out with this 2, and there's 2 left over. We cool? So my answer is 2 over x plus 2. And at that point, I'm done. Because I can't factor out the top. I can't factor the bottom anymore. I'm done. That's the answer. So what I'm asking you to do, and again, we're not solving anything. We're not solving for x at all. We're just reducing it. We're just taking something complicated like this and making it look a little bit prettier. Yes, this is your homework. Simplifying the variables. Yeah, exactly. And I think that here's the thing that will confuse you on your homework, but once I explain it to you now, it will make a lot of sense. Do you remember back when I had like your answer was like 3x squared plus 4x plus 2 and I asked you, okay, what is A, B, and C? And so when you put in the answer, it would be A is 3, B is 4, and C is 2. You just compared this to that, and then it was done. The thing about it is, I don't know how to ask you to type in this answer into the computer. So what I did was I said something like, and I think I remember saying something like, if this were ax squared plus bx plus c plus, plus c over dx squared plus ex plus f, a, b, c, d, e, f, then what are the numbers that are going to go in here? And I asked it in that kind of style, right? So then for this answer specifically, c is equal to 2, e is 1, and f is 2, and everything else is 0. Right? That's probably the only confusing thing about the homework part. But I gave it to you something like, I might have even gone A, B, C, D, E, F, G, H, or something like that. Not that bad. Okay? All right. Let's apply some other stuff that I think that once you extend this concept, it's still pretty easy, not hard. Math is kind of all about making sure that you're very methodical and very careful with what you're doing. Let's try this one. 3 over x plus 1 plus x over x minus 2. All right. So we're adding fractions. And these fractions don't have a common denominator, right? So this is, basically we're going to go through the exact same steps as what we did before, but we're going to be applying it to this. So for this first fraction, I'm going to multiply the top and bottom by x minus 2. Because I'll tell you what my common denominator is right off the bat. It's x plus 1, it's a plus, times x minus 2. That's what my common denominator is going to be. Okay? So, for this first fraction, I'm going to multiply it by 3 over x plus 1 times x minus 2 over x minus 2. Are we cool? All right. And then for this second fraction, I'm going to multiply both the top and bottom by x plus 1. Oh, sorry. X over x minus 2. And I'm going to multiply both the top and bottom by x plus 1. Are we cool? So now that I have a common denominator, this thing right here, I can add them. So I just add everything in the numerator. 3 times x minus 2 plus x times x plus 1, all divided by my common denominator. Yeah? All right. The only thing I would want to do now is probably to distribute everything on top. I'm going to hold off on distributing the bottom for now. But when I have two things that I'm trying to add. I definitely want to distribute everything and then combine like terms. Exactly. Essentially, I want to get everything looking kind of like this, where I have a parentheses between everything. That's my goal, because that allows me to cancel stuff out. I can't cancel things out on the bottom and the top right now, but let's see what happens. Would you guys freak out if I told you the numerator was 3x minus 6 plus x squared plus x? Okay. I think that my answer to your question is, why can't I cancel out the factor terms up here? Is that what you're asking? Okay. Okay, think of it like this. 5 times y plus 8 times x over 5 times 8. I can't cancel out an 8 out of the top and the bottom because there's not an 8 in every single term. I can't cancel out a 5 out of the top and the bottom because there's not a 5 in every single term. If, however, this 8 wasn't an 8 but it was a 10, then I could cancel out a 5 on top and a 5 on bottom, because I could factor out a 5 out of here, and then this would be 5 times y plus 2x over 5 times 8. And then these would cancel. That's true. Does that make sense? Now this is just a side note from what, I'm diverting from what you wanted because I'm trying to answer your question. I thought it was a good question. Yeah, I can only cancel things. I can only cancel things after I've fully factored them. So my goal is to try to fully factor them, because canceling is the best part at the end. That's the part that I really enjoy. Let me kind of finish this problem off, if that's all right with you. I'm going to simplify this to make him x squared plus 4x minus 6. So all I did here was I rewrote him in highest to lowest order, and I also combined like terms. Very cool? Why is the only one? Okay, wait. What are you talking about, Lucas? I don't understand your question. Oh, okay. Lucas, what you're asking is, why is there only one x plus 1 times x minus 2 over here? Whereas over here I had this thing plus this thing? Is that what you're asking? Because remember back when we had like 5/4 plus 3/4? I make it 8 over 4, not 8 over 4 plus 4, or 8 over 4 times 4. You take the common denominator, and your answer, when you're adding fractions that have like terms, is going to have the same common denominator as the things you added. Does that make sense? When you look at this, it makes a lot of sense. 5 over 4 plus 3 over 4 is 8 over 4. Just like this over a common denominator plus this over a common denominator is this plus this over that common denominator. Are we cool? Now, honestly, there's a lot of writing, and for those of you who just showed up, like Genesis and Cameron, I don't know if you just showed up, but this could look very confusing, and this could look terrible, and it's not. It really isn't. It's just adding fractions. We're just doing it the big boy style. All right, let me finish this one off. I think I might be able to factor it. Why don't we try that? X squared plus 4x minus 6. Let's see if we can factor that down. X Can you guys think of any? X squared plus 4x minus 6. So that would be 3 and 2 works. I can't think of any off the top of my head. So, actually, this is your answer. I guess that was kind of a junk problem to use, but, you know, it is what it is. Now, to put your answer in the homework, you're going to have to FOIL this out and then put it in standard form, you know. How can you tell if it's done? I think that's a really good question. You try factoring it as best as you can. If you have to use the quadratic equation, then don't. Don't use the quadratic equation on that, because the quadratic equation will probably give you, if you can't factor it right off the bat, then the quadratic equation won't give you something pretty like that. And the whole point of factoring it down, so it's pretty like that, is to is so you can cancel things out on top and the bottom. Let's try another one of these. Cool? Yeah, and then for the answer, I want the top and the bottom to be in standard form, so you can, you know, tell me what the A, B, C, and D coefficients are, and so on and so forth, that kind of stuff. Yeah, yeah. But that's really, I mean, the math is done. The next step is really just a matter of me not knowing how to have you type this into the computer, so I made up a way of you guys doing that. We cool with that? It's not bad, really. All right, I'm going to erase. I'm going to move on. Remember, this is being archived. I archive everything. Let me try a harder one. All right, let's try this one. 9x plus 8 over 7 minus 3x minus 6 over 2x. I'm sorry, this is x minus 7. All right, write the problem down. Okay, here's what I'm going to do. We can do that, Sophia. We could totally factor out a 3 out of here. I like the way you're thinking about this, but before I do that, let me just kind of do this step right here. Cool? So my common denominator I already know is going to be an x minus 7 times a 2x. Are we cool? It's basically this denominator times that denominator. That's it. So I guess the question you have to ask yourself is, what did you need to multiply the numerator 1 by in order to make it a x, or in order to make it look like that? Well, numerator 1 or denominator 1 looks like this. Denominator 2, or the final denominator, looks like this. The thing that's missing is the 2x. So I need a 9x plus 8, but I need to multiply that whole thing by 2x. Are we cool? And then for numerator 2, I need to remember to multiply that thing by an x minus 7. The only thing that makes subtraction a little bit harder than addition is this subtraction sign right here. That comes from this subtraction sign right here. Those are the same subtraction sign. You need to remember to distribute that negative after you're done playing around with this stuff. That's the only thing that would make it a little bit complicated. And I'm definitely going to give you a few problems like that, because I'm expecting you guys get burned on a couple times on that and then figure out how to do it correctly. All right? Making a mistake is not a problem. Learning your mistake that's the key. All right. I'm going to FOIL this thing out, and it's not really foiling, it's just distributing this 2x into here. And this becomes 18x squared plus 16x. Are we cool with that first part? All right. I have my subtraction sign here. And here's what I'm going to do is I'm going to put a big parenthesis or a bracket around here just so that I can remember that after I FOIL this out, I'm going to need to distribute this negative into there. Because I guarantee you, if you're not careful like that, you'll get messed up. So I'm going to FOIL this out, and that's just straight foiling. That's old school stuff. It's not hard. It's not new. This is 3x squared minus 6x minus 21x plus, oh shoot, what's 6 times 7? I'm not very good at math. 42? Yeah, good. So are you cool with what I did with foiling it? I didn't do anything freaky. All right. And on the bottom, I'm going to have my x minus 7 over 2x. Now, I think that one of the questions you might be asking yourself is, Mr. Dalday, why did you distribute this and FOIL this, but you didn't change the denominator? Right? And my answer to that would be this. My answer to that would be, because of this subtraction sign, I want to FOIL it out and then simplify it by combining like terms, that kind of stuff, and then factoring that, because essentially I want to get everything to look kind of like this. So let me FOIL this out. There is one step I want to do real quick. And if it's all right with you, do you mind if I don't rewrite everything? I'm just going to do this. Negative, positive, positive, negative, and make that a positive. And I'll drop the brackets. You guys see what I did? All I did, and I'm just making sure I'm being very careful with what, I didn't want to have to rewrite this again, but all I did was I changed that big negative into a positive, but I changed the sign of everything that it applied to. So if it was positive, it became a negative. It was a negative, it became a positive, and all of that kind of stuff. Why did I do that? Well, because I want to combine like terms across the board. You know what I mean? All right, so let's combine like terms. Let's see. 18x squared minus 3x squared, that's 15x squared. I've got let's talk about the x's. I've got a 16x plus 6x plus 21x. Is that correct? Yes. Okay. So what is 16 plus 6 plus 21? Is it 43? I'll take your word for that. I don't know. That's a tough one. And then minus 42. All over x minus 7 2x. Okay. So, Sophia, how do you know if you're done? Because actually, to be honest with you, I really wanted these answers to come out much nicer, but it's not. They're not coming out nice at all. I'm not very pleased with this homework problems I've chosen. How do I know if I'm done? I'm going to try to factor that. Okay? And that's a beast to factor. I'm going to let you know now. The point of trying to factor this is so that I can maybe, if I'm lucky, I can have one of those factors on top be x minus 7. Blah, 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 blah. Right? Maybe if I'm lucky, I can have one of those, I can factor this down and have one of those things be an x minus 7. If that were the case, then I could cancel out the x minus 7s. Got it? And then my answer will be whatever this is left over divided by 2x. But I'll tell you what, I'm looking at this now, and I don't think x minus 7 is one of the factors. I could use polynomial long division, but I'm just looking at this and I'm like, it's not going to work. It really isn't. I wanted the answer to come out like that so that I can show you folks why we're factoring this stuff down in the first place. But essentially, this is your answer. You have to stop here. Actually, here, I'll tell you what the answer you want in your computer is. It's 15x squared plus 43x minus 42 divided by 2x squared minus 14x. So I think if I asked you this, to put this in the computer, you would say A is 15, B is 43, C is negative 42, D is 2, E is negative 14, and F is 0. That's it. All right. Did you guys ask any questions? Yeah. If it doesn't factor to a whole number, then don't try the quadratic equation. Yeah. All right, let's do another problem. Is that all right with you? So again, this is not hard. This is really easy. It's just, it looks a little bit different. All right. Now, let's do another one of these. We'll go with this. When I asked you to, when dealing with fractions, I think that everyone would say multiplying and dividing fractions is way easier than adding and subtracting fractions, right? Would you agree? And it's because adding and subtracting fractions deals with making a common denominator and making sure they're the same denominator, and then you can add them or subtract them or whatever. But multiplying, you just multiply the top and multiply the bottom and you're good. So here, let me show you a multiplying problem. This one's not bad at all. 5x plus 15 over 2x times 8x minus 2 over x squared minus 9. Are we cool? Here's what it is. I'll show you how to do it. It's really easy. 5x plus 15 times 8x minus 2 divided by 2x times x squared minus 9. I didn't need to do anything as far as finding common denominators or anything. I just multiplied the top with the top and the bottom with the bottom, and I put parentheses in there just so I can make sure I'm being very careful. We cool? All right. Can I factor something out of this thing right here? Is this in simplest? Is this parentheses simplified, or can I do something with it? I can pull out a 5. All right, so I'm going to go 5 times x plus 3. Are we cool with that? Now what about this one? Can I do something with that? Two. Okay, so this is 2 times 4x minus 1. So all I did here was I pulled out a 5 out of here and a 2 out of here. If I were to FOIL all of this together, this would be the exact same thing. You guys agree? Anything complicated here? No, not really. All right. The 2x I can't factor down anymore. That's pretty much just down as easy as you can go. But the x squared minus 9, can you factor that? Yeah. It's x minus 3 times x plus 3. Now remember I told you that there's a formula for this thing called the difference of squares. X squared minus 9. 9 should be a buzz number in your head. 9, oh, hey, he said 9. That's exactly, immediately I think of 3 times 3. Whenever I hear 9, I think of 3 times 3. It's 3 squared. So you have a square minus a square, then you get x plus, x plus 3, x minus 3. Those are your numbers. Cool? Now we have this in the form that we want. This is my favorite part about factoring, or about rational functions. Killing things. Is there anything on top that matches with anything on bottom? I can cancel out the x plus 3. Perfect. What else? There's one more. Come on. Rhymes with shoe. Starts with a T. You can cancel out a 2. Yeah. Because there's a free 2 up on top and a free 2 on the bottom. All right. So what is my answer? I basically look at the aftermath and see what's left over. Okay. So I think one of the things that you're saying in your head is like, well, wait a second. I like Sophia's comments. That requires a lot of perception. That requires me to think a lot about, like, you know, I didn't think immediately off the top of my head, hey, I can break this x squared minus 9 down, right? Is that what you're thinking? All right, here's where I'm talking to you about the hints that I like. As soon as I got an x plus 3 up here, I was wondering if there was an x plus 3 I could find somewhere on the bottom so I can cancel them out. As soon as I saw the x plus 3 up here, I thought, if only there was an x plus 3 on the bottom. So, just like I saw the 4x minus 1 over here, I thought, if there was a 4x minus 1 on the bottom, I could figure something out. So what I did here was I just said, as soon as I saw this, I thought, where could I get an x plus 3? Oh, hey, I remember this one formula. It's x squared minus 9. Now, I hate to say it, Sophia, but hints is kind of the whole point, or like being able to pick up on these small things is kind of the whole point of learning things. If everything was obvious, well, it'd be easy to teach. It'd be easy to do. But do you see kind of my thought process here? As soon as I saw a x plus 3 up here, I thought, where in the denominator could I get an x plus 3? That's something that I remember doing way back when. You know, another thing too is, as soon as I saw a 2x down here, I thought to myself, where can I get a 2? Like I can pull out a 2 out of it, so it's free for me to divide. I could pull it out of here. So that's kind of my recommendation on things. Let me do one more for you. And to be honest with you, this is fun to me. It's not hard at all, I think. It's just, let's see. Let's try this one. This one looks hard. It might be hard too. I don't know. I'm just doing it as best as I can. Divided by 16x plus 72 over 2x plus 4. All right, write the problem down. Step 1. This looks horrible. It really isn't. Let's try it. First thing I'm going to do is I'm going to get rid of this division sign. I don't like dealing with division signs. I like turning them into multiplication signs and flipping it over. We cool with that? All right. Can I pull anything out of this thing up here? Is that correct? Yeah, it's 27. Can I pull anything out of the 6x plus 27? Three, yeah. Oh, why didn't I think of that? Of course. 3 times 2x plus 9. Cool. can I pull anything out of the... Oh, and also since it's multiplication now, I can basically just do that and make it one big parentheses. Are we cool with that? I took the numerator of the first one, I multiplied it by the numerator of the second one. And the denominator of the first one times the denominator of the second one. All right. So can I factor anything out of this 2x plus 4? Oh, 2, good. So 2 times x plus 2. Okay. Can I factor anything out of the 18x squared plus 36? I can pull a 9 out. Can I pull out an 18? What's 18 times 2? That's 36. I can pull an 18 out. In fact, not only that, I can pull out an 18x out. Do you see that? Because this is 18x squared plus 36x. There's an x in both of them. So the biggest number I can pull out is 18, and then the biggest variable I can pull out is an x. Can I pull anything out of the 16x? I'm thinking 8 goes in with that. And another thing, Sophia, off the top of my head, here's what I'm thinking is I definitely want it to be 2x plus 9. The reason why I came up with 8 is because I said, I want it to be 2x plus 9 over here. So in order to make that 16 and 2, I would have to pull out 8. Does 8 go into 72? Oh, yeah, it does. Awesome. Why did I want to make it a 2x plus 9? Just curious. Because I have the 2x plus 9 over here on the top. So I can cancel things out, and this is my favorite part of the game. 2x plus 9 gets killed by that 2x plus 9. This x plus 2 got killed by that x plus 2. Let's see, can I even go even further before I multiply everything out? Yeah, sure. This 2 turns that into a 4. And then this 18, that turns this into a 6, and this gets killed. So my answer is 1 over 24x. So this crazy looking thing is 1 over 24x. Why is it not 1 over 6? Well, remember there's a 6 here and there's also 4 over here, so that's how I got 24. And then there's still this x left over that I don't want to forget about. There, that's your answer. So if I were to put this answer in my homework, I would say A is 0, B is 0, C is 1. The D is 0, E is 24, F is 0. You know what I mean? So, what do you guys think? What's your thoughts? Is this all right or is it hard? All right. It's kind of weird. It's a love-hate. All right. Yeah, I actually really like them. They're like games to me. Let me do how's about 2 more and then we'll be done with class. We'll just finish class a little early. Sound good? All right. Let's see if 2 more of these floats your boat. Now, I don't know what I assigned for homework, so we're going to have to deal with it. But 2 minus v over 8v. Actually, I don't want to do that one. Let's do this one. 3 over x minus 1 plus 2x over 3. Okay? All right. My common denominator, and I'm going back to doing the adding and subtracting because those ones are going to be easier than the... Wait, what did you say? Couldn't we? Oh, yeah. Yeah. You just multiply. What you're doing is essentially cross multiplying. So this would be 9 plus 2x times x minus 1 divided by x minus 1 times 3. Are we cool with that? you're essentially you can read the common denominator really quickly. It's very easy. You just multiply that times that. See? And then you think to yourself, well, what is this missing? What is this missing from the common denominator? Well, this thing is missing a 3, and that's why I got a 9. And this thing is missing my x minus 1, and that's why I have my x minus 1 there. All right. Let's FOIL out the top. 9 plus 2x squared minus 2x all over x minus 1. And then I'm going to 2x squared minus 2x plus 9 over x minus 1 times 3. All right, here's what my thoughts are. I'm wondering if I can factor this thing down. And I'll tell you what, it's only worth factoring down if there's an x minus 1 on top. So if there's an x minus 1 on top, then this has to be 2x over here. You guys see how I'm kind of going about doing this? I don't know the answer. I don't have it off the top of my head. So I'm just showing you guys what my thought process is. The only point of factoring this thing down, I can't pull out a 2 out of everything. I can't pull a 3 out of everything. I would want to pull a 3 out of everything because if this were a 3 and this were a 3, it would be nice so that I can cancel out that 3, right? But I can't. So I'm thinking that the only point of factoring this thing down is if this top were x minus 1. So if this top were x minus 1, then this first term has to be 2x squared, so I need to have that be 2x. Now all I have to do is figure out what sign and what number goes right there. That's all I have to do. And if that's 9, or if this is a 9, then that has to be a negative 9. Maybe practice. Do you understand where I got the idea that this has to be a negative 9 back here? Because these two numbers have to multiply out to be that. So negative 1 times negative 9 is positive 9. Does this actually work? I don't think it does. This would be 2x. Let me FOIL this out. This would be 2x squared minus 9x plus, or minus 2x plus 9. That's 2x squared minus 11x plus 9. So that doesn't work. So you can't factor that. Or even if you could factor it, it's not worth factoring. How's that for an answer? Because the only thing that it would be worth factoring is if it yielded an x minus 1 somewhere out there. But it doesn't. So at this point, we're done. That's our answer. I hate to say it, but none of my addition and subtraction problems ended up working out for themselves. All right, wait. What is it? Oh, I see. Sophia, what you're saying, and I like your thought process, but you caught yourself, is you said, hey, this 2x squared minus 2x, I can pull out a 2x out of there, and then it would be x minus 1, right? Out of just these first two terms of this trinomial. The problem is you're only doing it to the first two terms of a trinomial. The fact of the matter is there's 3 terms that you would have to deal with. But there are some situations like that where you would do some tricks like that. We'll get into those. But this isn't one of those cases. That would be more advanced rational functions, which I think I will teach you how to do. Lucas, what did you... Oh, you saw this. Oh, I see, Lucas. You're thinking that, hey, this x minus 1 can cancel out with that x minus 1. Is that what you're thinking? Lucas, that would be like saying 5 plus y divided by y. Hey, the y on top can cancel out with the y on the bottom. That's absolutely not true. you have the plus 5 there, and that, you know. If, on the other hand, this was 5y plus y squared or something like that, then yes, you could make that a 5 plus y divided by 1. You could cancel out a y on top and a y on bottom, because you could first factor out a y out of everything in the numerator, if that's the case. Yes, and Sophia's answer is correct as well. If it were a 5y over y, then you could factor out the top and the bottom, the y out of the top and bottom. But if it were like a 5y plus 3, then you no longer can. You get it? What you'll have to end up doing is you'll have to end up hoping that it's going to be subtracted like a 2y plus 3. And then watch what's going to happen here. This is what I'm getting, the point I'm getting at is, what's going to end up happening here is you're going to have to distribute this negative here. This becomes 5y plus 3 minus 2y minus 3 over y. And then this 3 cancels out with that 3, and you end up getting 3y over y. And so your answer is 3 in this case over here. It's because this second thing that we added to it or subtracted from it, it ended up killing off that extra number, and then it ended up giving us something that we had only y's in. I'm answering questions that are just a little bit divergent from the topic, but it's still, relevant. So hopefully that didn't confuse you. What do you guys feel about this topic? Because we're going to be spending the next week and a half, not even a week and a half, I think 2-3 weeks on rational functions. And this is like the beginning of it. This is the basics of it. All right. The next topic I'm going to cover is vertical asymptotes, and it's not really that hard. Chapter 2. Let me just take a look at what we're covering coming up. Let's see. I think chapter 2 was vertical asymptotes, or not chapter 2, but part 2 was vertical asymptotes. Apparently Khan showed you a lot of this stuff. Yeah, it's really just taking stuff you already know about how to do factoring and actually applying that stuff. I'm just taking a look real quick. Okay, so we're going to talk about vertical asymptotes, and then we're going to talk about end behavior, and then we're going to talk about graphing. Ooh, graphing is a lot of fun. Now, what is this? Chapter 5, or part 5 is determining what? Graphing is really great. Determining the symbolic. Oh, I see. Chapter 5 is actually a lot of fun too, because I think what I do is I give you the graph, and then I ask you to give me the equation. So for functions, or for all of this stuff, what we're going to do is we're going to basically learn how to, you know how we did it with quadratics, where we basically became the calculator, not just the calculator, but the graphing calculator. And we're awesome like that. Like we know what we're doing because we're awesome. Well, that's what we're going to do with that's what we're going to do with this stuff, is we're going to take this complicated looking thing and we're going to graph it. That's coming up, all right? In fact, you'll find a lot of the similarities of what we did with quadratics to this stuff. In fact, do you guys remember about the stretching gummy bear and the compressing gummy bear and all of that kind of stuff? You're going to find a lot of similarities with those things. So I think that you'll like it. All right. Let me know what your thoughts are. I hope to see you guys soon. Who ended up attending class anyway? I'm just wondering.
Let's see, let me go back to default settings. All right, so we got Alana, Bradley, Cameron, Lucas, Sophia. Awesome. Yeah, cool. I'll talk to you guys later. Hope you guys really enjoyed it. Stretching is, I don't know what you're talking about. Oh, you're talking about vertically stretching. Usually you're talking about like multiplying by a whole number, a number bigger than 1. It could still be a fraction, but it's a fraction that's bigger than 1. All right. Talk to you later. Okay, bye.